we're going to start taking a look at polynomials. You guys have been using polynomials, but we just haven't named them. So first thing we got to talk about is what is a term? So a term is simply a number or a product of a number and a variable. Okay, so some things that are terms are things like 5x, 4, 2/3 y squared, anything like that would be considered a term. One thing that we want to know is that terms have only multiplication. So a single term is never going to have addition or subtraction in it. So now let's look at what a polynomial is. So a polynomial is a single term or a sum or difference of multiple terms. So this is where we get into starting to link terms together. So we've seen a lot of these before, especially if you think of graphing, linear equations, even solving equations. We had some polynomials. So something like x plus 1. So we have two terms linked together by addition. 3x squared minus 7x plus 4. That would also be a polynomial. But you do want to remember that a single term we can still refer to as a polynomial. So something as simple as 5, we can still say is a polynomial. So what do we want to do with these? We want to start naming polynomials so that when you say the name of a polynomial to someone, they're going to know some characteristics. So the first thing that we look at in a polynomial is how many terms does it have? And we're going to give some of them some special, very specific names, and then as they get bigger and bigger, we're going to give them generic names. So a one-term polynomial is called a monomial. All right, so it has only one term. So something like 5x or 4 or 3y squared. Those are all monomials, and you'll notice that there's no addition, no subtraction. We're not linking multiple terms, there's only one. So we can get a little bit bigger, two terms. This is called a binomial. Okay, so this is where we have two terms. So we're going to start linking things with addition and subtraction. 5x plus 1 or 3y minus 7, right? Two terms linked by either addition or subtraction. All right, then we get to 3. This is called a trinomial. Right, so an example of this might be 7x to the 4th minus 3x plus 2. All right, we have 3 terms, 1, 2, 3. Okay, so those are kind of our 3 special names that we're going to be worried about, but we do have polynomials that are larger than that. So what do we do? So if we have something like a 4-term polynomial, we're simply going to call it a 4-term polynomial. And we can shorten that to just poly. Okay, so what might that look like? Say 5x to the 6th plus 2x to the 4th plus 3x squared minus 2. So we have 4 terms. We can underline them. 1, 2, 3, 4, linked by either addition or subtraction. So that's a 4-term. So now what about any term? So an n-term polynomial where n is just some number, 5 terms, 6 terms, 7 term. We're just going to put the number of terms and then say that polynomial. So anything bigger than a trinomial is always just going to be an n being the number of terms, term polynomial. All right, and they can get as big as you want them to be, right? We could have a 20-term polynomial if we wanted to. Okay, so that is the first way that we identify different types of polynomials. But polynomials have another identifying feature, and that has to do with the degree of the polynomial, okay? So a degree in a term is basically the sum of the exponents of all of the variables in the term. So most of the time we're going to be dealing with a single exponent, but sometimes we might have more. So all we want to do for this is look at the degrees, or the exponents, really. So here, the only exponent is 3. So this would be a third degree. And we're going to get special names in a little bit, but this is just practice for identifying degrees. So here we have a y squared, but don't forget this x really has a 1 on it. So we have 1 plus 2, so this would also be a third degree term. Okay, here we only have one exponent, it's a 2, this would be a second degree. All right, so now what is the degree of a polynomial? So what happens when we have many terms, not just one? So we identify the degree of the polynomial as the term with the greatest degree. So we look for the term with the greatest degree, and that's going to determine the degree of the whole polynomial there. Okay. So because of this, we like to write polynomials which are in standard form. So that's where we list all of our terms by taking the degrees in decreasing order. So we have our degrees from least, or excuse me, not least, from greatest to least. Okay. So before we get into doing that, we want to talk about some names for these. So they do have special names. A 0 degree term. Okay, so if we're thinking about this guy, we said degree is the sum of the exponents of all the variables. So a 0 degree term we call a constant because it's just a constant number, like 4 or -5. There are no variables. So it would be like having an x to the 0 power or a y to the 0 power. So it's just a constant number, never changing like a variable would be. A first degree we call a linear. All right, so something like 2x plus 5 or 3y. The highest degree is 1. All right, next up, a second degree. We call this a quadratic. Okay, now you might be used to quad meaning 4, but we get this, I believe, from Greek, not Latin. And quad, if I'm correct about the where this comes from, quad actually means square-like. So it means 2 in this case. So that gets a little tricky because it's coming from a language that we're not used to dealing with for prefixes of words. But this does mean square-like, so it means a second degree, something like x squared plus 3x minus 5, right? Where our highest exponent, our biggest exponent there is 2. All right, third degree, this is cubic. And it might look something like -3x cubed, or x to the third, minus 2x plus 7. So here our highest degree is that 3. Once we start getting a highest degree bigger than 3 is when we go into the generic, and we would just call it an nth degree. So like a 5th degree or 6th degree. Okay, so let's take a look at some actual polynomials and start naming and putting them in standard form. Okay, so first thing, a couple of pieces that we need to fill in. The coefficient is the number part of a term. So if I have 3x, that number in front of the variable, that is my coefficient. Okay, then we have a special name for the one that comes first. It's called a leading coefficient, and that is the first term in a polynomial that is put in standard form. All right, so if we're looking at this polynomial, we want to kind of identify its pieces here. So we have this 6, that's our leading coefficient. which I often shorten to COEFF, save yourself some writing, leading coefficient. This 2 here is still a coefficient, but it's not the special one that's put out in front. And this 4 is the constant term, right? So it doesn't have any variable. And you can see that this is in standard form because our exponents go 3, 2, and this one we don't have one, so it's 0. So we have biggest to smallest for our exponent. All right, so we want to name this. Polynomials, we always name based off their degree first, followed by the name detailing how many terms they have. So our degree is always based off what's the highest degree. So you can go back to the previous page, and a third degree we call a cubic. Okay, and then we have 1, 2, 3 terms. So this is a cubic trinomial. Okay, and now it has its name. So every polynomial is always going to have 2 names describing its degree and its number of terms. So let's go name a few more. So the instructions say, put in standard form and name each polynomial. So we have 2 things that we want to do. So this first guy is not in standard form yet. So I want to make sure to put it in standard form. So we have a first degree term, second degree, and then 0. So I want to put them in biggest to smallest. So we have a 3x squared plus, because that's a positive, 2x plus 8. So now it's in standard form and I can name it. This is a second degree, which we call a quadratic. And we have 1, 2, 3 terms, so it's a trinomial, like a tricycle, 3 wheels. Okay, next one. Not in standard form yet. Constants are 0 terms. This is a linear 1, so we need to put it in standard form. 5x plus 4. Then we can go ahead and name it. So our highest exponent is a 1, so this is a linear. And we have 1, 2 terms, binomial. Okay, like bi means 2, like binoculars, right? You look at 2 things. Okay, next one, 8x. So there's only 1 term, so it's definitely in standard form because we can't rearrange that any other way. So we can just go ahead and name it. So it has an exponent there of 1, so our highest degree is a first degree, so it's a linear. And then there's only 1 term, so we call it a monomial. So mono means 1. That's the prefix we use for 1. All right, continuing on. Number 4, we got to put this in standard form. Got an exponent of 2, 0, 5 for our variables there. So let's put those from least to greatest. 2x to the 5th plus 9x squared minus 6. And now we can name it. So this is a 5th degree, and we don't have a special name, so we just call it a 5th degree. And we have 1, 2, 3, so it's a trinomial. Okay, last one. Got to reorder these. Just be careful about this negative out front. Make sure it stays with that term. So this is a 5x cubed minus 6x, and we're going to name it. Highest degree is a 3, so it is a cubic. And we have 1, 2 terms, so it's a cubic binomial.